Welcome to the world of Dreamside Traveler. Here, beneath the soothing sound of gentle rain, we journey through time and space, uncovering the mysteries of the past and diving into the most captivating pages of human history. This place is created for those who love exploring the world in the quiet of evening, for those who value peace while yearning to discover something new before sleep. If you enjoy what you're hearing, please give this video a like. It helps other people find our stories. Help us reach our first 1,000 subscribers in our club of nighttime history lovers. And the Dreamside Traveler channel will become your faithful guide to sleep. We're constantly adding new stories for your peaceful evenings. And if you have ideas about which historical topics interest you, or simply want to share your thoughts, leave comments below the video. I'm genuinely curious to know what inspires you. Now close your eyes. Feel this gentle rain outside your window. Allow yourself to relax. Our journey begins right now. In the quiet town of Torun, Poland, in the year 1473, a child was born who would forever change how humans understand the universe. His name was Nicolaus Copernicus. Back then, almost everyone believed Earth was the center of everything. But Copernicus grew up to be the man brave enough to challenge that idea. His early life was a mix of privilege and loss. When he was just 10 years old, his father, a respected merchant, passed away. After that, Copernicus's uncle, a powerful bishop, took charge of his education. Thanks to his uncle, Copernicus went on to study at the University of Krakow. There, he first met the subjects that would define his life: math and astronomy. But he didn't stop there. Copernicus traveled across Europe, especially Italy, where he studied medicine, law, and theology. Still, his passion remained with the stars. He learned to speak Latin, Greek, and Italian so he could read ancient books and knowledge from long ago. Yet, his real goal wasn't just to study the past. It was to understand the future of science. By day, Copernicus worked as a church cleric and a doctor, taking care of his duties and helping the sick. But when night came, he looked up to the sky, carefully watching how planets and stars moved. Over time, he grew troubled by the old model of the universe. This model placed Earth firmly at the center, with the sun and planets moving around it. However, it could not explain certain strange movements of the planets, especially what is called retrograde motion, when planets seem to move backward in the sky. Determined to find a clearer truth, Copernicus spent years observing and calculating. His work led him to a stunning conclusion. The sun, not the Earth, was the center of the universe. The planets, including our Earth, moved around the sun in a beautiful cosmic dance. This idea is called the heliocentric model. It made perfect sense mathematically, but was revolutionary because it challenged the deeply held beliefs of that time. Copernicus was cautious. He knew that sharing his findings could upset religious and political leaders who had long accepted Earth as the center of all creation. For many years, he kept his discoveries secret, refining his work carefully. Only when friends and students urged him did he agree to publish his book, De Revolutionibus Orbium Celestium, on the revolutions of the celestial spheres. The book came out in 1543, the same year Copernicus died. It is said that he saw the first printed copy on his deathbed. At first, his ideas were met with skepticism. Many thought they were just theoretical and too radical. The Catholic Church did not fully understand the importance of his work immediately. But over time, others like Galileo, Kepler, and Newton built upon his ideas, proving the truth of the heliocentric model. Copernicus's discovery laid the foundation for modern astronomy. It showed that stars and planets were not fixed around Earth, but part of a vast, ever-expanding universe governed by natural laws and precise mathematics. Tonight, as you gaze at the starry sky, imagine Nicolaus Copernicus centuries ago, sitting quietly by candlelight, pen in hand, charting the heavens with patient certainty. He did not seek fame or to start a revolution. He simply sought truth, and by doing so, he gave humanity the key to unlocking the mysteries of the cosmos. So rest well, dear dreamer, and remember, even the simplest questions, like why planets move the way they do, can lead to the greatest discoveries of all time. In the golden light of 16th century Italy, a boy named Galileo Galilei looked up at the sky with wide-eyed wonder. Born in the city of Pisa in the year 1564, he grew up surrounded by music and numbers. His father was both a musician and a man of sharp intellect. Though Galileo first began studying medicine at the University of Pisa, his heart soon belonged to mathematics and physics, fields that stirred his curiosity like nothing else. Galileo was never satisfied with simple answers. He questioned everything and sought to understand the world around him. He became fascinated by motion, how objects fall, roll, and move through space. Early in his career, he became a professor of mathematics at Padua, where he sharpened his ideas about the laws of motion and the very nature of reality. But more than anything, his eyes were drawn to the heavens, the mysterious lights far above. One clear evening in the early 17th century, Galileo aimed a telescope, an instrument he had improved himself, toward the night sky. With this humble tool, he unlocked secrets of the universe that no human had ever seen before. He discovered that the moon was not a perfect, smooth sphere as once believed, but a world scarred with mountains and valleys. He saw that Jupiter, the giant planet, had 4 moons orbiting it: Io, Europa, Ganymede, and Callisto, showing that not everything circled Earth. The Milky Way, that soft, cloudy band stretching across the night, turned out to be made of countless stars, each shining on its own. Perhaps most boldly, Galileo supported the idea first suggested by Copernicus. The Earth was not the center of the universe. Instead, the planets revolved around the sun. This idea was revolutionary and dangerous. At the time, society was deeply rooted in religious beliefs that placed Earth and humanity at the center of creation. Challenging this view meant confronting powerful religious authorities. Galileo's discoveries were met with disbelief and resistance by many of his peers, unwilling to let go of long-held views. Despite this, Galileo fearlessly published his findings and defended the sun-centered theory with great conviction. His book, The Starry Messenger, sent shockwaves through the intellectual world. While some praised him, others condemned him. The Church, which strongly supported the Earth-centered universe, saw Galileo's ideas as a threat. In the year 1616, Galileo was officially warned to stop supporting the heliocentric view. For a time, he remained silent, but his passion for truth could not be contained. In 1632, he published Dialogue concerning the two chief world systems, a brilliant work presenting the debate between supporters of the old and new cosmologies. Though written as a conversation among three characters, the book clearly favored the sun-centered system. This defiance led to Galileo's summons to Rome to face the Inquisition, a powerful institution that hunted heresy. Under threat of severe punishment, he was forced to recant his ideas. Yet, legend says that after his forced admission, he whispered, "E per se muove," meaning, "and yet it moves." Galileo spent the rest of his life under house arrest. His books were censored, and his voice silenced, but his mind continued to explore. Even confined, he wrote about motion and mechanics, laying foundations for modern physics. His ideas, once condemned, became the stepping stones for scientists like Isaac Newton and Albert Einstein. Centuries later, history honored Galileo's courage and vision. The Church admitted its mistake, and his name became a symbol of relentless curiosity and the brave pursuit of truth against all odds. So tonight, when you look at the moon, remember that long ago, Galileo gazed upon that same glowing world and saw not perfection, but a rugged landscape of craters and mountains. In doing so, he brought humanity one step closer to the stars. Under the vast and chilly skies of the Holy Roman Empire in the year 1571, a fragile boy named Johannes Kepler was born into a world riddled with war, superstition, and hardship. Though his body was weak, his mind was destined for greatness, one that would change the way humanity understood the stars forever. Kepler's early life was anything but easy. His family lived in poverty. His father was a soldier who vanished when Johannes was still young, and his mother, a healer using herbs, faced accusations of witchcraft, a dangerous charge in those times. Yet, despite these shadows, Johannes's bright intellect and deep curiosity about the heavens shone through. His talent won him a scholarship to the University of Tübingen, where he immersed himself in mathematics and astronomy. There he encountered the revolutionary ideas of Nicolaus Copernicus, who had boldly placed the sun, not the earth, at the center of the universe. This heliocentric vision captivated Kepler and would guide his lifelong quest. After his studies, Kepler became a mathematics teacher in the town of Graz, in what is now Austria. But it was during this time that his passion for the cosmos grew stronger. To him, the universe was not chaos, but a divine order, a grand design ruled by mathematical laws. His belief was deeply rooted in both his sharp scientific mind and his strong religious faith. However, Kepler's peaceful work was soon disrupted. Religious conflicts forced him to flee Graz, and he eventually found refuge in Prague, where he began working for the famous Danish astronomer Tycho Brahe. Brahe was a man of noble birth, flamboyant and exacting, who had spent years collecting the most detailed and accurate observations of the planets. Kepler, humble but brilliant, became his assistant, a partnership that would forever change astronomy. When Brahe died in 1601, Kepler inherited his vast collection of data. With great patience and skill, he searched for the hidden patterns behind the planet's movements. What he uncovered was nothing short of revolutionary. The long-held belief that planets moved in perfect circles was false. Instead, Kepler discovered that planets travel around the Sun in elliptical orbits, stretched circles with the Sun at one focus. This discovery was just the beginning. Kepler went on to formulate 3 fundamental laws of planetary motion. First, that planets move in ellipses with the Sun at one focus. Second, that a planet sweeps out equal areas in equal times, meaning it speeds up when close to the Sun and slows down when farther away. And third, that the square of a planet's orbital period is proportional to the cube of its distance from the Sun. These laws laid the foundation for celestial mechanics and paved the way for Isaac Newton's theory of gravity. They explained the movements of the planets with breathtaking accuracy, bringing harmony to the cosmic dance that had puzzled humans for centuries. Yet Kepler's life was filled with struggles beyond his scientific pursuits. He lived through times of religious wars and personal tragedies. He lost his first wife and several children to illness, faced exile, and even saw his books burned. His mother was imprisoned on charges of witchcraft, and Kepler fought passionately to secure her release. Beyond his rigorous scientific work, Kepler was also a dreamer. He wrote Somnium, one of the first works of science fiction, imagining a journey to the moon long before such ideas were popular. He pondered the possibility of other worlds and suns, envisioning a universe much larger and more wondrous than anyone of his time dared to believe. In his later years, Kepler dedicated himself to refining the Rudolphine tables, astronomical charts that dramatically improved the accuracy of planetary predictions. These tables guided astronomers and navigators for generations. Johannes Kepler passed away in 1630, worn but fulfilled. He had glimpsed the hidden architecture of the cosmos and shared its elegant secrets with the world. Today, his legacy shines on through the Kepler Space Telescope, a fitting tribute to the man who tirelessly sought order among the stars. So the next time you gaze up at the night sky, remember Johannes Kepler, the man who, against all odds, revealed the beautiful mathematics behind the planet's motion. He showed us that the universe is not a random chaos, but a magnificent masterpiece, a celestial symphony waiting to be explored. The year was 1546, and under the vast northern sky, in a grand castle in Denmark, a boy was born into a noble family. His name was Tycho Brahe. Though he was destined to inherit wealth and status, his true legacy would not be written in gold or titles, but among the stars themselves. Tycho's early life took an unusual turn. Though born to noble parents, he was taken, some say even kidnapped, by his wealthy uncle. This uncle raised him as his own son, ensuring Tycho received the finest education possible. From a young age, Tycho was fascinated by the night sky. While his family wanted him to study law, his heart was drawn elsewhere. When he was just 13 years old, Tycho witnessed a rare and awe-inspiring event, a solar eclipse predicted with impressive accuracy by astronomers. This moment changed everything for him. How could people, armed only with numbers and simple instruments, foresee the movements of the heavens? This question burned in his mind, and despite his family's wishes, he devoted himself to the study of the stars. Though he briefly attended university to study law, Tycho secretly pursued his passion for astronomy. One night, he observed a rare conjunction of Jupiter and Saturn. But the recorded positions of these planets were slightly off from what the current predictions said. This small discrepancy bothered Tycho deeply. To truly understand the universe, precision was essential. Determined to improve astronomical measurements, Tycho abandoned his law studies and committed himself fully to science. He traveled across Europe, learning from the greatest minds of the time, collecting knowledge like a traveler gathering stars in a jar. But the greatest opportunity came when King Frederick II of Denmark recognized Tycho's genius and gave him an island called Ven. On this quiet island, Tycho built something extraordinary. Uraniborg, the most advanced astronomical observatory of the 16th century. Unlike most astronomers who relied on small tools and rough calculations, Tycho designed huge, intricate instruments to track the stars and planets with unmatched accuracy. His observations were so precise they remained unsurpassed for decades. Even though he worked without a telescope, for many years Tycho carefully charted the sky. His work led to a discovery that challenged centuries-old beliefs. In 1572, he observed a bright new star, a nova, in the supposedly perfect and unchanging heavens. According to ancient beliefs, the sky was flawless and eternal, but this new star proved that the universe could change. Tycho had uncovered evidence that the cosmos was dynamic and alive. Tycho was not just a scientist. He was a man full of contradictions. Brilliant but proud, precise yet eccentric. He was known for his extravagant clothes and unusual habits, like keeping a pet elk that once died after drinking too much beer. He even wore a metal nose, the result of losing part of his real one in a duel sparked by a disagreement over mathematics. Stubborn by nature, Tycho refused to fully accept the heliocentric model proposed by Copernicus. Instead, he suggested his own hybrid system, where planets orbited the sun, but the sun itself orbited the Earth. Despite his brilliance, Tycho's fortunes changed after King Frederick II died. Losing royal favor, he was forced to leave Ven, taking his precious records with him. Eventually, he found refuge under the Holy Roman Emperor Rudolf II in Prague, where he continued his work. There, Tycho met Johannes Kepler, a mathematician destined to transform astronomy. The two were very different. Tycho, a proud nobleman with a commanding presence; Kepler, a poor but deeply thoughtful thinker. Their partnership was difficult but crucial. Tycho provided Kepler with the most accurate planetary data ever collected, and Kepler used this information to discover the laws of planetary motion. In 1591, Tycho Brahe died suddenly under mysterious circumstances. Some believed he was poisoned, while others thought he died from an infection after refusing to leave a royal banquet out of respect for court etiquette. Whatever the cause, his death marked the end of an era. Yet Tycho's legacy lived on. Kepler inherited his data, and using it, unlocked truths that even Tycho could not fully embrace. Planets do not move in perfect circles, but in ellipses. Without Tycho's meticulous observations, Kepler's revolutionary discoveries might never have been made. Tycho Brahe was a man of paradoxes, proud but brilliant, stubborn yet visionary. He never fully accepted the heliocentric universe, but his work paved the way for those who did. He measured the heavens with extraordinary care, bringing humanity closer to understanding its place among the stars. So tonight, as you look up at the sky, remember the man who devoted his life to mapping the stars with unmatched precision, the man who built an island observatory, who lost his nose in a duel, who kept an elk as a drinking companion, and who, despite his quirks, left behind a treasure of knowledge that changed the world forever. Rest well, dear dreamer, and know that the universe rewards those who dare to question, to measure, and to see beyond what others accept as truth. The stars above shine with the echoes of those who studied them. And among those echoes lives the legacy of Tycho Brahe, the last great astronomer of the naked eye era. In the year 1656, beneath the gray, cloudy skies of London, a boy was born into a world full of mystery, discovery, and endless wonder. His name was Edmond Halley, though today his name is most famous for a comet that visits Earth every 76 years. His impact on science stretched far beyond that glowing visitor streaking across the night sky. From his earliest days, Halley was filled with an unquenchable curiosity. His father, a wealthy merchant, made sure he had access to the best education available. At St. Paul's School, Edmond's talent for mathematics and the stars quickly became clear. By the time he entered Oxford University at just 17 years old, he was already a passionate skywatcher, eager to unlock the secrets of the cosmos. Halley's first big adventure took him far from home. In 1676, when he was only 20, he set sail for a remote island called St. Helena, deep in the South Atlantic Ocean. His goal was daring, to map the southern stars with precision like never before. The journey was tough. Violent storms, sickness, and the island's harsh conditions threatened to stop him. But Halley pushed on, carefully charting hundreds of stars with remarkable accuracy. When he returned to England, his work was so impressive that he was elected a Fellow of the Royal Society before even finishing his university degree. Halley's influence in astronomy was enormous. He studied how stars and planets move, diving deep into the laws that govern their celestial dance. But Edmond wasn't just an astronomer. He was a true scientist in many fields. He investigated Earth's magnetic field, mapped trade winds that guided sailors, and even studied the Earth's age by measuring how fast rivers carried silt into the ocean. His mind was as vast and restless as the universe itself. Yet it was a meeting with another brilliant thinker that changed history forever. Halley met Isaac Newton, a genius who had developed revolutionary ideas about motion and gravity. Newton, shy and reluctant to share his work, hesitated to publish his discoveries. It was Halley who encouraged him, even funding the printing of Newton's landmark book, Philosophiae Naturalis Principia Mathematica. Without Halley's support, the world might have waited decades to learn about the laws of motion and universal gravitation. Still, Halley's most famous breakthrough was yet to come. For centuries, people had feared comets as unpredictable omens streaking across the sky. But Halley saw a different truth. Comets followed the same natural laws as planets. By studying old records of comets seen in 1531, 1607, and 1682, he noticed something amazing. Their orbits were nearly identical. Halley boldly predicted these were not three separate comets, but one comet returning regularly. He forecasted it would appear again in 1758. Sadly, Halley passed away in 1742 and never saw his prediction come true. But when the comet returned on schedule, it was named in his honor, Halley's Comet. Halley's scientific curiosity didn't stop with comets. He helped pioneer studies of Earth's atmosphere, weather, and ocean currents. He explored air pressure's effects, how climate influenced navigation, and even designed an early diving bell that allowed people to explore underwater for longer times. His work showed a mind free from limits, always reaching for knowledge in every direction. Throughout his life, Halley served the scientific community with dedication. In 1720, he was appointed Astronomer Royal, following the great John Flamsteed. Even as he grew older, he tirelessly observed the moon and improved methods for finding longitude at sea. A vital skill for the expanding British Empire and its navy. Edmond Halley never lost his passion for discovery. Though he never witnessed the return of his famous comet, his legacy shines brightly. He was a man who saw order in the cosmos where others saw chaos, a champion of science when faith and reason often clashed. So tonight, when you look up at the stars, remember Edmond Halley, the man who dared to predict the path of a wandering comet, who helped bring Newton's ideas to light, and who showed us that the vast universe moves in rhythms we can understand. Sleep well, dear dreamer, knowing that just like Halley charted the heavens, your journey is guided by the light of knowledge, leading you toward new discoveries. In the year 1738, in the lively city of Hanover, Germany, a boy was born into a world where music filled every corner. His name was Friedrich Wilhelm Herschel, though history remembers him simply as William Herschel. From the very beginning, his life was wrapped in melodies and harmonies. He learned to play the oboe, violin, and harpsichord, and by the time he was just 14, he was already performing with the Hanoverian military band. But the peaceful rhythms of his early years were soon interrupted by the storm of war. Facing growing conflict, William and his brother made a bold decision to leave their homeland and start anew in England. There, William rebuilt his life as a musician, working as a composer and organist in the beautiful city of Bath, known across the country for its rich culture and vibrant art scene. Though music was his daily work and passion, it was the night sky that truly captured his imagination. After long days filled with rehearsals and concerts, William would turn his gaze upward, devouring books about stars, planets, and the vast universe beyond our world. Yet he quickly became frustrated. The telescopes available at the time were weak, unable to reveal the deep mysteries he suspected were hidden in the darkness above. Determined to see farther and clearer than anyone else, William decided to craft his own instruments. Alongside his sister Caroline Herschel, who would become a brilliant astronomer herself, he learned the delicate art of grinding and polishing mirrors. Step by step, they built telescopes far superior to those that anyone else had. By the year 1774, William had completed a powerful reflector telescope, and the night sky was ready to reveal its secrets to him. Then came a night that changed everything. March 13th, 1781. While observing the heavens, William noticed something strange. A small, faint object moving slowly among the fixed stars. At first he thought it was a comet, but as he carefully tracked its path, a stunning realization dawned on him. It was a planet. Not just any planet, but a new world never before seen by human eyes. He had discovered Uranus, the first planet found with the help of a telescope. This discovery shook the scientific world to its core. Until then, people believed the solar system had only 6 planets, known since ancient times. William Herschel proved that the universe was far bigger and more complex than anyone had imagined. So impressed was King George III. He rewarded William with a royal pension and appointed him the official royal astronomer. But William's curiosity did not stop there. With Caroline by his side, he set out on a grand mission to map the night sky. He carefully catalogued thousands of stars, uncovering pairs of stars dancing together, clusters of stars glowing faintly, and mysterious nebulae shimmering in the dark. For the first time, humanity began to see that the cosmos was not a random scatter of points of light, but a vast, ordered structure. A universe filled with countless wonders. One of William's most remarkable achievements was his discovery of infrared radiation. By passing sunlight through a prism and measuring the temperature just beyond the colors visible to our eyes, he found a new kind of light, one we cannot see but can feel as heat. This invisible light would later become vital in physics and astronomy, opening new doors to understanding energy and the universe. Meanwhile, Caroline Herschel, once his assistant, blossomed into a respected astronomer. She discovered several comets, catalogued nebulae, and became the first woman to receive a salary for scientific work, a true pioneer in her own right. Together, the Herschels were more than just a family. They were explorers of the heavens, shining lights that led humanity to new frontiers. William continued building larger and more powerful telescopes, including an enormous reflector nearly 40 feet long, the greatest of his era. Through these giant eyes, he glimpsed deeper into space, than anyone before him, revealing the shape of our own Milky Way galaxy, and suggesting it was but one of many galaxies scattered through the universe. William Herschel was not merely an astronomer. He was a dreamer, an adventurer who turned away from the earthly stage to perform in the vast theater of the stars. His legacy lives on in every telescope that scans the night sky, in every scientist who dares to seek the unknown, and in the endless discoveries that continue to expand our view of the cosmos. So tonight, when you look up at the sparkling sky, imagine William Herschel's hands gently adjusting his telescope, searching for something beyond the horizon, something no one had dared to see before. He believed the universe was infinitely greater than anyone had dreamed, and he proved it true. Rest well, dear dreamer, and know that, like Herschel, you too can reach beyond what is known, into the vast and wondrous unknown. In the year 1629, in the vibrant Dutch Republic, a child was born into a world alive with creativity, discovery, and a restless hunger for knowledge. His name was Christiaan Huygens, a man whose brilliant mind would shine among the greatest thinkers of his time. From an early age, Christiaan showed a remarkable gift for understanding the mysteries of nature, especially the patterns and secrets woven into the cosmos. His father, Constantijn Huygens, was no ordinary man. He was a poet, diplomat, and musician, deeply connected to Europe's cultural and intellectual circles. Growing up in such an inspiring environment, Christiaan quickly developed a passion for science and mathematics, soon surpassing even the best tutors. But what truly captured his imagination was the vastness of space and the sparkling wonders it held. The 17th century was a golden age for astronomy. Telescopes were still a new and magical invention, revealing worlds beyond what anyone had dreamed. Inspired by Galileo's discoveries, Christiaan began grinding lenses with incredible precision, building some of the finest telescopes anyone had ever seen. His patience and skill paid off with astonishing results. In 1655, while peering through one of his powerful telescopes, Huygens discovered something no one else had before: a large moon orbiting the distant planet Saturn. This moon, which we now call Titan, was the first satellite found beyond those circling Jupiter. This discovery hinted at the complexity and beauty of the outer planets, reminding humanity how much more there was to explore. But Christiaan's fascination with Saturn didn't stop there. For years, astronomers had puzzled over the strange shapes seen around Saturn, those mysterious handles or ears that Galileo himself could not explain. Using his superior lenses, Huygens was the first to reveal the truth. Saturn was encircled by a thin, flat ring floating around the planet, separate and distinct. He even guessed correctly that this ring was made up of countless tiny particles, all dancing in harmony as they orbited Saturn. His insight was far ahead of his time, a fact only confirmed centuries later by space missions. Yet Huygens was not just an astronomer fascinated by distant worlds. His curiosity reached into the very nature of light itself. At a time when many believed light traveled as tiny particles, Christiaan proposed something revolutionary, that light moved in waves, much like ripples spreading across a pond. This wave theory of light would later become a cornerstone in physics, helping us understand phenomena like diffraction and refraction that shape the way we see the world. His genius extended beyond the heavens and light to something closer to home: time. Knowing that accurate timekeeping was vital for navigation and scientific study, Huygens invented the first pendulum clock in 1656. This breakthrough allowed clocks to keep time with unprecedented precision, transforming everything from daily life to long sea voyages. For centuries, pendulum clocks were the heartbeat of human progress. Life, however, was not without its challenges. The political and religious turmoil of the era forced Huygens to move often, spending much of his later years in Paris under the support of King Louis XIV. There he continued to dream and write, even imagining in his work cosmotheories, the possibility that other planets like Titan, Mars, or Venus might be home to life forms unlike our own. A bold thought in an age still bound by tradition. As his health waned, Christiaan stepped away from public life, but never from his quest to understand the universe. When he passed away in 1695, he left behind a legacy that would inspire generations. He had unveiled the secrets of Saturn, transformed our grasp of light, and revolutionized the way we measure time. So tonight, as you look up at the stars, remember Christiaan Huygens, the man who first saw Titan, who revealed the rings of Saturn, and who dared to imagine worlds beyond our own. He showed us that the universe is not just to be admired, but to be understood. Rest well, dear dreamer, and know that, like Huygens, you too can reach beyond what is known and discover the unseen wonders of the cosmos. More than 2,000 years ago, beneath the clear and starry skies of ancient Greece, a man named Hipparchus gazed upward with a mind hungry to understand the secrets of the cosmos. Long before telescopes, advanced mathematics, or modern scientific tools existed, Hipparchus made discoveries that would forever change how humanity views the heavens. With nothing but his keen eyes and an unrelenting curiosity, he became one of the greatest astronomers of the ancient world, a man who measured the universe with astonishing accuracy. Hipparchus was born around 190 years before the Common Era in a town called Nicaea, located in what is now modern-day Turkey. Though little is known about his early life, his legacy is preserved through his meticulous observations and remarkable mathematical insight. Unlike many of his contemporaries, who often mixed myth and philosophy with their study of the stars, Hipparchus insisted on logic, measurement, and proof. He is best remembered for creating the first known star catalog, a monumental achievement for his time. Before Hipparchus, stars were seen simply as eternal, unchanging points of light fixed in the sky. But Hipparchus noticed something different. He observed that certain stars shifted their positions ever so slightly over long periods. To capture this, he carefully recorded the locations of more than 850 stars, ranking them by brightness. an early version of the magnitude system astronomers still use today. Yet Hipparchus' most astonishing discovery came when he compared his star measurements with those made by astronomers centuries before him. He realized that these shifts weren't caused by the stars themselves moving, but because the Earth was slowly wobbling on its axis. This wobble, now known as the precession of the equinoxes, means Earth's orientation changes gradually over thousands of years, altering the position of the celestial poles. This insight shattered the old belief that the heavens were fixed and unchanging, revealing a dynamic and shifting universe. Hipparchus did not stop there. He sought to understand the motions of the moon and the sun with unmatched precision. His observations allowed him to create one of the earliest accurate models of lunar and solar motion, refining the length of the year to within minutes of modern calculations. This improvement made calendars more reliable, essential for agriculture and civic life in ancient societies. One of his greatest contributions was the development of trigonometry, a branch of mathematics that deals with the relationships between angles and distances. Hipparchus compiled one of the first trigonometric tables, enabling calculations that would become fundamental not only for astronomy, but also for navigation and engineering. His innovations in spherical geometry formed the backbone of celestial navigation, guiding explorers and sailors for centuries. Despite his brilliance, much of Hipparchus' original work was lost over time. Unlike some Greek philosophers, he did not write grand literary treatises. Instead, his knowledge survived through fragments and references by later scholars, most notably Ptolemy, who praised Hipparchus and incorporated his findings into his own astronomical models. Hipparchus' influence endures even today. The European Space Agency launched a satellite named Hipparchus in 1989, honoring the ancient astronomer's legacy. This space telescope conducted one of the most precise surveys of stars in history, mapping over 118,000 stars with an accuracy that Hipparchus himself could only have dreamed of. So the next time you look up at the night sky, remember Hipparchus, the ancient mind who, without modern technology, charted the stars, uncovered the secrets of Earth's motion, and laid the foundation for the science of the cosmos. He proved that the pursuit of knowledge is not limited by time or tools, but by the human will to seek, question, and understand. Sleep well, dear dreamer, and know that the spirit of discovery shines on, just as it did over 2,000 years ago when Hipparchus first measured the heavens. On a chilly autumn night in 1918, an astronomer sat quietly under the vast expanse of the night sky. His name was Harlow Shapley, and unbeknownst to many, he was on the verge of forever changing how humanity understood our place in the cosmos. Through his careful study of ancient star groups called globular clusters, tight collections of stars that orbit the outer edges of our galaxy, he would reveal something astonishing. Our Milky Way was far larger than anyone had ever imagined, and our sun was not at its center, but instead lived quietly on its outskirts. Harlow Shapley was born in the year 1885 in a small town in Missouri. His path to becoming one of the most influential astronomers was anything but straightforward. At first, he dreamed of being a journalist, fascinated by stories and the power of words. But fate had a twist in store for him. A simple mistake on his university application enrolled him in an astronomy class instead of a journalism program. That chance event turned his gaze from earthly stories to the stars above. Shapley pursued his new passion at Princeton University, where he studied under Henry Norris Russell, one of the era's leading astronomers. There, Shapley honed his skills, learning how to carefully observe the stars and perform the precise calculations needed to understand their secrets. But it was only when he joined the Mount Wilson Observatory in California that his name became linked with one of the century's greatest discoveries. Shapley was fascinated by globular clusters, those dense balls of stars floating in the halo of the Milky Way. Using a revolutionary method developed by another brilliant astronomer, Henrietta Swan-Leavitt, he focused on special stars called Cepheid variables. These stars pulse rhythmically, brightening and dimming in a way that allows scientists to calculate how far away they truly are. By meticulously measuring these changes in brightness, Shapley could determine the distances to the globular clusters with unprecedented accuracy. What he found shocked the scientific world. The clusters were not scattered randomly, but formed a vast, organized pattern centered not on our sun, but on a point far away in space. For centuries, people believed the sun was at the heart of the universe. Shapley's data told a different story. The Milky Way stretched over 100,000 light-years across, far larger than anyone had imagined. And our sun was located not in the middle, but on the outskirts, nestled in one of its spiral arms. This discovery shattered the long-held view of a sun-centered universe. Our solar system was not the center of everything. Instead, we were small travelers on the edge of something immense and majestic. Shapley's work sparked fierce debates. Many astronomers were hesitant to accept his findings because they challenged centuries of conventional wisdom. Yet, as more observations confirmed his conclusions, the famous Shapley-Curtis debate in 1920 helped pave the way for a new understanding of the cosmos. Though some details of Shapley's conclusions were later corrected, his work fundamentally changed how we see our galaxy. As director of the Harvard College Observatory, he also championed the role of women in astronomy, hiring and promoting some of the most brilliant female scientists of the time, continuing a legacy started by those before him. Shapley didn't stop there. He played a key role in recognizing dwarf galaxies, small companions to our Milky Way, and saw our galaxy as part of a much larger cosmic landscape. He believed deeply in connecting science with society, pushing for greater public understanding of astronomy. For him, learning about the universe wasn't just about stars. It was about how this knowledge reshaped humanity's view of existence, even as the expanding universe was discovered later by Edwin Hubble. Shapley's studies of galaxies and their patterns laid important groundwork for modern cosmology. He passed away in 1972, but his legacy lives on. Thanks to him, we now know our home galaxy is far grander than we ever imagined, and that we are not at its center, but humble explorers on its edge. So tonight, when you look up at the stars, remember Harlow Shapley, the man who measured the Milky Way and showed us that we are part of a vast, beautiful story. His discoveries remind us not as rulers of the universe, but as curious travelers journeying through the wonders of the cosmos. Rest well, dear dreamer, for even at the edge of a galaxy, the adventure of discovery never ends. Carl Sagan, poet of the cosmos, in the busy borough of Brooklyn, New York, in the year 1934, a boy was born into a world full of dreams and endless possibilities. His name was Carl Sagan. Though the city was where he first opened his eyes, his heart was always drawn to the stars above. Carl would grow into more than just a scientist. He became a storyteller, a man whose voice and words inspired countless people to look up and wonder about the vast universe. From a young age, Carl was fascinated by everything beyond our planet. When he was just a boy, he visited the 1939 New York World's Fair. There, he saw exciting visions of the future, space travel, exploring other planets, and all the incredible possibilities science might bring. It was during those early years that he learned something amazing. The sun is only one star among countless others in the sky. Each of these stars might have its own planets. This thought amazed him and sparked a lifelong thirst to understand the universe. Carl chased his passion with great determination. He studied physics and astronomy at the University of Chicago, where his curious mind never stopped asking questions. Under the guidance of brilliant mentors, he became an expert in planetary science, especially interested in the atmospheres of other worlds like Venus, Mars, and Jupiter. His early work was groundbreaking. He suggested that the extreme heat on Venus came from what we now call a runaway greenhouse effect, an idea that later warned us about dangers facing Earth's climate. He also proposed that Titan, Saturn's largest moon, might hold vast lakes made not of water, but of liquid methane. Carl helped design famous space missions like Mariner, Voyager, and Pioneer, which not only explored our solar system, but also carried messages from Earth into the vast unknown. But Carl Sagan did not want to stay locked away in universities and laboratories. He believed science should belong to everyone. He had a special gift. He could make the vast cosmos feel close and personal. He took the most complex scientific ideas and turned them into beautiful stories, mixing facts with wonder. This talent shined brightest in his television series, Cosmos, a personal voyage, which first aired in 1980. Through Cosmos, Carl invited millions of viewers on an incredible journey through time and space, explaining the origins of life, the birth of galaxies, and the nature of the universe itself. With his gentle voice and contagious enthusiasm, he showed that science is not just about numbers and formulas. It's about curiosity, awe, and understanding our place in the vast expanse. One of his most famous ideas is that we are made of star stuff. This phrase captured his philosophy perfectly. Carl saw the universe not as something distant or separate from us, but as something deeply connected to our very being. Every atom in our bodies, every molecule on Earth, was formed in the heart of ancient stars. We are not mere observers, we are part of the universe's ongoing story. Carl's influence went far beyond television. He was a prolific writer, publishing books like The Dragons of Eden, Pale Blue Dot, and Contact. Each book carried a powerful message. Science is a bright candle in the darkness, lighting up the mysteries of existence. His novel Contact was later turned into a film, sharing his hopeful vision of humanity's first encounter with intelligent life from another world. One of Carl's most remarkable contributions was his work on the Voyager missions. He helped create the Golden Record, an extraordinary message sent into space aboard Voyager 1 and Voyager 2. This record contained music, sounds, and images representing Earth, designed as a cosmic time capsule for any extraterrestrial beings who might find it one day. It was a symbol of his belief that humanity should reach beyond itself, sending messages of hope and curiosity even into the darkest reaches of space. Carl Sagan was also a strong defender of reason and critical thinking. He fought against superstition and pseudoscience, believing that skepticism and the scientific method are essential tools in a world full of misinformation. His book, The Demon-Haunted World, warned about the dangers of abandoning rational thought, urging us to keep questioning and exploring. Despite his deep scientific knowledge, Carl remained humble. He often spoke about the pale blue dot, a photograph of Earth taken from billions of miles away by Voyager 1. In that tiny, fragile speck floating in the vast darkness of space, he saw the sum of human history, our victories and mistakes, our wars and peace, our loves and losses. He reminded us that in the grand scheme of the cosmos, we are small, yet capable of amazing things. Even after his passing in 1996, Carl Sagan's ideas, words, and spirit continue to inspire scientists, dreamers, and explorers. His influence lives on in the search for life beyond Earth, in the renewed excitement for space travel, and in every child who looks up at the night sky filled with wonder. Tonight, as you close your eyes and drift into dreams, imagine Carl Sagan's voice whispering through the cosmos. Picture yourself floating among the stars, visiting distant worlds, and seeing the universe as he did, full of beauty, mystery, and endless possibility. Sleep well, dear dreamer, and remember, we are all made of star stuff.